Hello everybody, thank you for joining me today. Today I'll be discussing AWS Digital Twins for energy asset visualization. I'll be discussing some of the services that AWS provides to make this an easier process for you, especially if you've been struggling to create a digital twin for your assets out in the field. My name is Sean Murray and I'm a Senior Partner Solutions Architect here at AWS. I want to discuss, before we proceed with AWS services, what exactly is a digital twin? A digital twin is a digital representation of the physical asset that may be out in the field. You're taking information from sensor data, you're taking information from state or behavior data or third-party systems such as potentially weather or seismic or geographic information, pulling all of that information in and dynamically representing that on your digital asset that you've created. From there, being able to leverage all of that information to help drive better business outcomes. These better business outcomes can be things such as predictive maintenance or planning. Based on what a digital twin is, what are we doing here at AWS to make digital twins easier to create? Well, what we have here is AWS IoT TwinMaker. IoT TwinMaker is a service that will allow you to more easily create digital twins by accessing data no matter where it exists today, whether that's out at the field or through third-party integrations and in third-party systems. It allows you to then model that information based on your environment to create this three-dimensional view that exists within TwinMaker and can be placed on a Grafana dashboard, which I'll be showing in a later slide on how you can interact with this and again help drive some of those better business decisions and help work towards your business goals. Some of the great features that IoT TwinMaker provides are data connectors, model builder, scene composer, and app toolkit. I'm going to start by discussing the data connectors. These data connectors that are pre-built into IoT TwinMaker allow you to collect sensor information or data from third parties and pull that into TwinMaker to dynamically update your digital twin as you build it. Now, with these data connectors, there are pre-built data connectors built into TwinMaker, but if there's other systems that you're trying to connect to, you also have the flexibility to create your own connectors as you connect to third-party data systems to enhance the data that you're leveraging to update your digital twin. Model Builder allows you to create the virtual representation. So as you're building out that model from your spec diagrams and other sources of data and tying the points from your data to that model to be dynamically updated. Another great feature is the Scene Composer. Now, I'll show this a little bit later on, but with Scene Composer, one of the great things that you can do is bring some life to your digital twin. So here you're able to apply some of your physical environment and enrich the data for your digital twin so that when you integrate it using the app toolkit into a dashboard, as I mentioned previously, such as Grafana, you have a much more realistic view and the interaction with this digital twin can become more valuable and usable by your end users. So to sum up IoT TwinMaker, and you may be asking, why exactly would you want to use AWS IoT TwinMaker? Well, with IoT TwinMaker, as I previously mentioned, by integrating to your existing data sources, working with your data that you already have either in the cloud or out on-prem and in the field, such as connecting to existing databases. You may have IoT devices, you could have sensor data, PLCs, RTUs, perhaps you have historians or web camera data. Again, by having some of these pre-built connectors or connecting your own can really make creating your digital twin a simpler process. You can also then integrate with and leverage AWS services that exist for data analytics, perhaps for forecasting. If you have your own SageMaker or other AI ML models that you want to bring to your assets and asset optimization, again, being able to leverage all of that information can really make a valuable digital twin a simpler process. And then finally, one of the great features with IoT TwinMaker is being able to leverage existing CAD diagrams and 3D models along with the Scene Composer to really enrich that digital twin And I'm hoping to highlight that in a little bit here, where you can then display that on a Grafana dashboard for your business users. I'm going to walk you today through a use case that we have here at AWS to really highlight the digital twin. What I'm going to be speaking about here is a collection of 3D printed wind turbines, which represent the field implementation that you may have with your with your physical assets. Within this physical asset, and what I'm highlighting here with these 3D printed wind turbines, is a sensor, a motor to run the wind turbine to collect RPM information. There's temperature sensors, vibration sensors, and all of that information that we're collecting from these physical edge devices is being pulled into IoT TwinMaker. It's being sent to the digital twin, which can then be modeled, and there's some predictive information that's being built off of that, which I'll be highlighting in a second here. As you can see here on the inside of these 3D printed models, you can see the little motor that's running, some of the sensors, as I'd mentioned previously, the temperature and vibration sensors, and how all of that information then is sent to an edge device, which is then pulled into AWS IoT Core. And then that information is leveraged on the digital twin to allow a virtual interaction with the device, along with other information around maintenance and future planning. As you start to go through and build your digital twin, leveraging IoT Twin, I really wanted to show here that after seeing the physical device, when you get into the service, you're able to then build a three-dimensional model here. You can create a hierarchy of components, tying those components using rules back to the data that you're pulling in from the field, creating thresholds and alarms and alerts so that you can actually start to monitor and see what's going on in the field. So you can see here, this is a low fidelity model of that 3D turbine. A lot of this was built leveraging AutoCAD diagrams. Again, you see the motor and the turbine leveraged and then translated into IoT TwinMaker to create that 3D virtual environment that you can interact with. As you can see here, once one turbine has been modeled, it can be replicated to and tied to each of the colors that you saw previously. So in this case, we have 5 wind turbines that have been modeled and are copies of each other. Previously in the past, even creating some of these low fidelity digital twins can oftentimes require quite a bit of custom work. It's very manual and can be slow, which can increase the barriers to adopting digital twins. With IoT TwinMaker, simplifying a lot of the creation of these twins based off of the AutoCAD files, as I've sort of previously shown, can really simplify the process of creating the digital twin and tying it back to that data that you're ingesting. Again, increasing the ease of adoption and hopefully increasing how quickly you can create these digital twins and adopt. As I'd mentioned, being able to compose scenes, so taking multiple digital twins, placing them on the same plane so you can visualize those assets. Again, here you can see within TwinMaker, you're able to position those relative to each other. You can create additional tags and on different axes, be able to move the data around, interact with it. There's lots of different rules and settings that you can put in place here. Again, all of this is used to help enrich your digital twin as you bring it to life. And then being able to take that representation and put it onto a dashboard, again, presenting this to your users to give them a more complete view of what's going on in the field. So with this dashboard here, you can see at the top that scene composer of having multiple devices or field devices represented together in a spatial location, but then being able to select an individual turbine and narrow down into it to see what's actually going on at that sensor, at the sensor within that device. So at the bottom left there, you can actually see a top-down view of an individual turbine where there's a warning that's been thrown. Maybe perhaps it's hit a threshold that would indicate a problem or a potential future problem. On this dashboard here, just to highlight what can be shown and what can be seen here, we have the vibration over time, we have the RPMs over time, we have an operational state, some gearbox acceleration, so as the RPMs are changing over time, and being able to, again, narrow down when a problem's occurring to tie back to other sets of information that are occurring at that time. There's also some different ways you can visualize things such as RPM and temperature. Again, as close to real time as possible when you're pulling that information from the field. And then also looking at things such as power output and being able to determine, in this case, if there's a problem with the device, that may be an indicator shown through information such as a reduced power output. So this is just really showing how you can leverage a digital twin along with the information that you're collecting at the field to not only interact with that digital twin in IoT TwinMaker, but also use that information to make actual business decisions or real world decisions. So now that we've seen what the digital twin dashboard and visualization can look like in the end, I wanted to just show one more time that path from the edge device to your digital twin and what that can look like in a real world example. So in this case, again, going back to this example, we're connecting to our edge asset, collecting information such as temperature settings or temperature information at a given point in time. We're pulling that data into a local edge computing device, which is then leveraging the IoT MQTT protocol, sending that information to our AWS IoT Core service. Then leveraging an IoT rule and an IoT action, we're able to then send that information to a location such as a dashboard that you may build, or in the case that I've been highlighting through this talk is an IoT TwinMaker dashboard, a digital twin. Anyway, what we're really talking about here is being able to collect that information by connecting to your device, transporting it in an AWS service, and storing that information in a way that's good for your end users. So really, to sum everything up, I want to talk about, again, how AWS IoT TwinMaker is, in our use case for energy asset visualization, helping speed up the process of creating digital twins, being able to provide useful information to your operations and planning and other business units through potentially an end-user web application to make better decisions when it comes to things around those physical assets. Those decisions can help with minimizing downtime, predictive maintenance, with planning energy distribution based off of what's occurring out in the field. And all of that's occurring in this use case here through IoT TwinMaker. That digital twin is pulling in information from your real-time sensors, real-time data. It's all being tied back to a virtual model which was created based off of AutoCAD diagrams and enriched through other three-dimensional models that were created. You have the ability to use some of those auto connectors to speed up the process to connect to video feeds and connect to other third-party information, such as geospatial metadata or any other third-party application that provides that data. And if the connector doesn't exist, being able to create your own connector and having that flexibility to pull in that information, and ultimately making the digital twin for your application and organization that is quickly and rapidly deployed and allowing you to make better business decisions. Just want to thank you again for joining me today as we discussed how AWS is helping simplify the process of building digital twins through the use of IoT TwinMaker here at AWS. And I wish you the best of luck on your journey as you create these digital twins and visualize your energy assets out in the field. Thank you.